Good morning, chemists, and welcome to our second lesson in our electrochemistry unit, or our redox unit. Today we're going to be taking a look specifically at what is a redox reaction. So let's go ahead and jump right in. So to kind of kickstart this lesson, I love to use the example of our gorgeous Statue of Liberty and talking a little bit about kind of the history of the Statue of Liberty. So the Statue of Liberty was a gift from France to the US, and when the US received the Statue of Liberty, it was pure copper, okay? Meaning that beautiful, shiny copper penny that you get, that brand new penny, is what our Statue of Liberty used to look like. And after, obviously, it was erected and it's had time to sit, our Statue of Liberty is now green. And so why is it that the Statue of Liberty turned this green color? So what I'd like to do is take a look at the reaction, kind of what one of the things that might be happening, and we kind of have to think about the different elements that the Statue of Liberty is exposed to, right? It's not just oxygen, carbon dioxide, or nitrogen, it's water and salt and all sorts of things. So this is an oversimplification of kind of what's going on at the Statue of Liberty, but I did want to just take a look at the reaction between copper and oxygen. So to kind of write out our reaction here, copper is going to react, okay, with oxygen gas, and it's going to undergo a synthesis reaction. Remember, that's two different elements coming together to form one compound. And the compound formed is copper to oxide, okay, copper to oxide, and we need to make sure to balance this equation. So I have 2 oxygen on my reactant side, I need 2 oxygen on my product side, and we have now 2 copper on the reactant side. So again, how do we name this compound here? Well, this is going to be copper to oxide. You'll notice that as we're getting closer to the end of the year, I like to throw in review where we can. Why is it named copper 2 oxide? Well, remember that copper is a transition metal. And when we have transition metals, we need to name the compound so that it indicates the charge that's present on that ion. So copper, because it is in a 1-to-1 ratio with oxygen, oxygen forms that -2 charge, so copper is going to form a +2 charge. And so hence our name, copper 2, 2 representing that charge on the metal ion, copper 2 oxide. So let's go ahead and assign all of our elements an oxidation number. We've already gone through and done our compound, copper, the 2+, the oxygen, the 2-. And all we're left here with is elemental copper and elemental oxygen. And as a review from our oxidation numbers, remember an oxidation number represents the number of electrons lost or gained in that current species. Now, copper in its elemental form has not lost or gained any electrons, and therefore it's assigned a 0, right? It's in its elemental form, okay? And oxygen, O2, again, also in its elemental form, and therefore, as a result, it's assigned an oxidation number of 0. Now, using these oxidation numbers, we can actually take a look at what happens from copper, the copper element to the copper ion and the oxygen element to the oxide ion. What happens in terms of electrons? So in terms of electrons, what happens to copper in the reaction? Well, what we're looking at here is copper is going from a 0 to a +2, right? A 0 to a +2. So is that losing or gaining electrons? Well, copper is going to lose 2 electrons to form the Cu +2 ion. Remember that positive charge indicates that we've lost electrons and we now have more protons than electrons in our ion. Okay, and then what happens to oxygen? Well, again, oxygen goes from O2, okay, to O minus 2. So O2 or O is going to go from a 0 to a minus 2. And so oxygen has lost, or I'm sorry, gained. Where did I get lost from? 2 electrons to form O minus 2 ion. Now, this leads me into what is a redox reaction? This is an example of a redox reaction. Redox standing for reduction and oxidation. Now, a lot of times when I teach this lesson, my students at the beginning of the year, at the beginning of the lesson, like to tell me that the Statue of Liberty is being oxidized. And initially, students tend to think that oxidized means that that the Statue of Liberty is reacting with oxygen. But the term oxidized doesn't always mean reacts with oxygen. Oxidized has to do with a loss or gain of electrons. And so let's take a look at what is a redox reaction. So a redox reaction, okay, is going to be a reaction which involves the loss or gain of electrons, okay? And there's two parts to it. Redox, again, is a combination of reduction and oxidation. So let's go ahead and define each of those. So reduction, the reduction portion of the reaction is going to be a gain of electrons. The way I like to think about this is reduction means that our charge is being reduced. It's becoming lower than it even was. And that can get a little bit confusing. But if you think about reduction as becoming more negative, right? Then that's easy to remember. Gaining electrons means that the charge is going down, right? We're gaining more negative, our charge is decreasing, okay? Which means that oxidation, okay, indicates that there has been a loss of electrons, okay? And in oxidation, our charge increases, okay? Now, again, if we look back to our initial reaction and we say that the copper was being oxidized, is that actually the case? Is that true? Well, again, copper was losing 2 electrons, and so it is true that this is an oxidation reaction, and that when we say that the copper is being oxidized, that's true. The oxygen, on the other hand, is being reduced, right? It is gaining electrons. All right. Now, how can you really remember this? Again, I'm going to give you like 15 million different ways. Pick whichever one works for you. But, you know, there are 2 great mnemonic devices that we can use here to help us remember redox reactions. The first is going to be oil rig, okay? And the mnemonic device stands for oxidation is loss and reduction is gain, okay? So oil rig, oxidation is a loss of electrons, reduction is a gain of electrons. And the second one is Leo says grr, like a lion. Leo the lion says grr, okay? And the Leo the lion says grr stands for a loss of electrons is oxidation and gain of electrons is reduction. So you can choose whichever of those 2 is easier for you to remember. They mean the same thing. They're just going to help us out to determine which species is being oxidized and which is being reduced in a reaction. And anytime I'm looking at redox reactions, I always put it right at the top of my paper. Now, another shortcut way to recognize a redox reaction without going through and determining if the species are losing or gaining, I will tell you that there is a shortcut method, and that is to say that synthesis and decomposition reactions and single replacement reactions are always redox. Basically, any reaction that has something in its elemental form is going to be a redox reaction. Okay? All right, so let's do a little bit more practice with redox. Let's go ahead and assign an oxidation number to each element in the reaction. So let's start with anything that's elemental. That's the easiest to me because anything that's an element means that it's assigned a 0 oxidation. Okay, so element, and we have our 0 oxidation. Another easy one to look for is oxygen. Oxygen is almost always a -2. Okay, and then going from there, the zinc and the copper, we're going to have to use the uncrisscross rule to figure out. So sulfate, the ion, SO4, carries a -2 charge. If I have one sulfate and one zinc, my zinc is now a +2. In my second reaction, or on the product side, sulfate again, 1-to-1 with copper, which means copper is a +2. Okay, and that means that my sulfur, we'd have to calculate using the SOS table. Okay, or kind of a shortcut method of the SOS table, 2 times 4 gives us -8. Zinc is +2, so sulfur has to be +6. And again, -2 times 4 gives me -8, okay? And therefore, sulfur is still a +6, okay? So looking at this reaction, we need to determine which element from the reactants, lost an electron from reactants to products. So again, loss of electrons is oxidation. Loss of electrons means that our charge is increasing. So looking at our reaction, we only have 2 species whose charge changes. We have copper to copper 2+, and zinc 2+ to zinc 0. Which of these 2 has the charge increasing? Well, our charge is increasing going from copper to copper 2+. 0 to +2 is a loss of electrons or an increase in charge. So our element that lost the electron, okay, was going to be the copper, okay, because it went from 0 to 2 and it became more positive. Okay? Which was the species oxidized or reduced? So again, loss is oxidation or oxidation is loss, and therefore this was oxidized. Okay? Which element gains an electron from reactants to products? Well, again, we have zinc going from +2 to zinc becoming 0. So +2 to 0 is a gain of electrons. So zinc gains 2 electrons and becomes more negative. Okay, and as our charge is going down, that means our species is being reduced. Excellent. All right, so which element did not lose or gain any electrons? There's actually 2 in this case. If we pop back up, sulfur and oxygen, or that sulfate ion, actually does not gain or lose any electrons. It stays a +6 and a +6 and a -2 and a -2. And anytime we have something that doesn't gain or lose, we actually call that a spectator ion. So we'll say our SO4 minus 2 or sulfur and oxygen, okay, their charges didn't change. Okay, and we call this a spectator ion. Okay, and a spectator ion is substance or species which does not lose or gain electrons. Okay, and therefore does not participate in the reaction. Okay, hence spectator. If you're not playing the sport, you're a spectator. So if you're not taking part in a reaction, you are a spectator. Okay, so let's take a look at a couple more examples. Okay, so let's go through and assign our oxidation numbers. Both Mg and S are elemental, so 0 and 0. Guess what? Let's do our second reaction while we're here. Both hydrogen H2 and oxygen O2 are elemental, both 0 and 0. Mg and S, Mg is group 2, so it's always a plus 2. That means that if Mg is a plus 2, sulfur is a minus 2. For H2O, O is a minus 2. I have two H's, each H is a plus 1. So whenever we're going through these reactions to determine which species is being oxidized and reduced, I like to do exactly what I've been doing. I like to show Mg is going from Mg0 to Mg plus 2, 0 to plus 2. My charge is increasing. That's a loss of electrons. And for sulfur, S is going from 0 to minus 2. Okay, that's a gain of electrons. And that should help me out. Again, at the top of my paper, I like to put my mnemonic device, oil rig. Oxidation is loss. So which species was oxidized? Our oxidized species is Mg. And again, it's Mg that's being oxidized. It's Mg that's losing electrons, not Mg plus 2. Which species was reduced? S is our species being reduced. Reduction is a gain of electrons. And again, it's the S that's being reduced, not the S minus 2. Okay, let's take a look at our next reaction. H goes from 0 to plus 1. Okay, that's going to be a loss of electrons. O goes from 0 to minus 2. That's a gain of electrons. Okay, which species is being oxidized? Oxidized is loss. That means that my H2 is being oxidized. Which species is gaining? O2 is gaining, okay, and being reduced. So from there, the last thing I want to talk about is oxidizing agents and reducing agents. Something that is considered an oxidizing agent. Now, I always like to introduce this term with, what is an agent? Like if I was a Hollywood star, what would be an agent? What would my agent do? What's the purpose of my agent? The purpose of my agent is to get me a job, right? To do the work for me, to make my job possible, okay? And so the oxidizing agent literally makes oxidation possible. So it's the species which makes oxidation possible, okay? And which species makes oxidation possible? Well, in order for something to be oxidized, it has to lose electrons. If it has to lose electrons, then who's it losing those electrons to? There has to be somewhere for that species to lose them to. So and this is where things get a little crazy, my oxidizing agent is actually going to be the species which is reduced, right? So in our reaction above, hydrogen cannot be oxidized without oxygen taking its electrons. So my oxygen is my oxidizing agent, where my hydrogen is being oxidized. Okay. From there, our reducing agent is the same idea, but opposite. So species, which makes reduction possible. Again, reduction, the gain of electrons isn't possible without a species that's there to lose the electrons. And so therefore the species that is oxidized is our reducing agent. Okay. All right, guys, I know the video was long. I am sorry, but there's no other homework tonight. Have a fantastic evening, and I will see you guys tomorrow.